5A siapa assistant? Kuan Siong, Kuan Siong. Baru masuk Morning Kuan Siong. Jangan lupa ambil attendance tu 5A. Logan baru masuk. Okay. Ni ada daripada kelas lain batch 2020. So nanti you ambil yang you punya attendance kelas 5A saja. Okay. Rahman ni. Sampai separuh. Okay. Pressure in liquid. I thought you have learned about pressure for the surface P equal to F over A. Form 4 ada tak? Pressure. Pressure untuk yang surface area punya. Maybe in chapter force and motion 1. Ada tak? Okay. Chapter 2.1 now pressure in liquid. You see the picture here. A big dam. The photograph shows water being released from a dam, okay, with a big pressure. Yeah, the outlet of the dam is near the base of the dam. Base of the dam. Why it broke the outlet at the base of the dam? Why? And then, why does the water shoot out at high speed? And then, what are the factors that affect water pressure? So this one today, kita tengok yang pressure in liquid. Okay, now you have learned. I thought you have learned this one. P equal to F over A. Pressure equal to force over surface area or area in contact. This one. Ini mesti dah belajar. Okay. So this one, if the area is smaller, pressure will become pressure will higher. Smaller area, pressure higher. Smaller area, pressure higher, and vice versa lah. If surface area bigger, pressure will decrease. Okay, increase, decrease. So pressure is inversely proportional with surface area or area in contact. Okay, now in liquid, pressure in liquid, the formula is P equal to HPG. Rho GH. Saya dah biasa dengan rho GH. P equal to rho GH. So samalah. Cuma bila kita dah biasa, so saya akan guna rho GH. Okay. P equal to rho GH. Rho stand for density. Okay, this one density. Rho. Ni saya dah ajar daripada form 1 kan. Okay, density equal to mass over volume. Mass over volume. Density equal to mass per unit volume. Okay, and then for pressure in liquid, we have P equal to rho GH. Density times gravity and height or depth. Height or depth. H stand for height or depth. Okay, the depth is from the surface of the water, from the surface of the water. Okay, now how to derive this formula, this pressure in liquid, from the formula that you have learned before, P equal to FA and density. Okay, right. Now this one, dia hanya bagi tahu, dia revise balik apa yang dah belajar. V, what is V? Volume equal to base area. Okay, we know that volume equal to area times height. Okay, and then mass. Mass equal to volume times density. Maksudnya ini daripada density. Dia tukarkan balik, ambil volume. Okay, volume equal to M over rho. Dia ambil M. Dia ambil M. So M equal to rho V. Okay, this one weight mg. Okay, mg, rotation acceleration, pressure F over A, or weight over A. Okay, so how to derive? Okay, saya nak tunjuk dekat tepi ni. Okay, you have learned P equal to F over A. F over A. So where the F come from? For the pressure that exert on an object in liquid. Yes, let's say ini ada tank water, full water, and then we have an object or a point here. Okay, there's a pressure exert on this object. So now we must consider the object force or the weight, the weight of the object inside the liquid. So F equal to mg, weight equal to mg, and then A, how to find A? A come from volume. Volume equal to area times H. So A equal to what? Volumes divided by H. Siapa yang nak masuk? Ada yang nak masuk tadi? Tak sempat, dah hilang lah. Okay. A equal to V over H. Right, V over H. Siapa nak masuk ni? Kevin. Okay, lagi siapa lagi? Kat sini 20 orang. 20 orang termasuk yang another class. Okay, sambung balik. Okay. Okay, P equal to rho GH kita nak derive. Now we want to derive P equal to rho GH from P equal to FA and density. Okay. Okay, A equal to V over H. Okay, now for density equal to mass times mass over volume. Mass over volume. Itu ke tak saya buat P equal to FA, F equal to mg, okay, A V over H, okay, A V over H, V A H, okay. Okay, now from density equal to P V, P equal to M equal to P V. Macam pelik je ni. Sekejap Won't you less meeting? Line you all ni clear ke tak ni? Hmm. Okay. Hmm. Ya. Baik. Sambung balik. Tukar. Yang tadi dah betul. So yang F ni kita derive from F equal to mg because the weight exerted by the object, the weight of the object, weight. Okay, and then we have A, mg over A. Now for density, we convert the density first. We take out m from density. We know that the rho equal to m over v. Density equal to mass over volume. So mass equal to rho v. Right. Okay. So from here, m equal to rho v over A. Pressure equal to rho v over A. Okay. Rho g v over A. This one PV. Okay, this one is rho v, and then g over A. Okay. Now v over A equal to h from the volume. We derive this one, or we substitute this one into h. We know that volume equal to A times h, surface area times height. Right. Now to measure volume, area, the area times height. Right. So convert this one. We take h only, v over A. So now we can get pressure equal to rho g h. This one keluarkan, tukar kepada h. That's how we derive rho g h from P equal to Fa and from density. Okay. Number 1, P equal to Fa, convert mg. And then number 2, tukar dia punya density, PV, density. And then number 3, baru dapatkan yang H. Then number 2, PV, density. And then number 3, H, rho GH. Okay. Lihat. Okay, next. The liquid pressure is calculated using the following formula. Remember this one. Pressure in liquid, any object in the liquid. Okay, we have P, H, rho, G. Kalau dalam exam pun dia boleh state formula macam ni, and then you define balik where P what, H what. If the question asks you the definition, what is the definition of pressure in liquid, so you can state the formula and then define where P equal to liquid. If you cannot remember the dia punya statement, tak boleh ingat maksud dia yang dalam ayat tu, so you boleh buat dalam formula. Right. Factors affecting liquid pressure. So this one you just look at the equation. Look at the equation. So what happen if density increase? What happen to pressure if density increase? Pressure also increase. And then the gravity, yang ni not to involve lah. So this one density and height or depth. Height or depth. Okay, height or depth. Depth. Okay. What happened to pressure with if depth increase. So pressure also increase. Okay, means that pressure is directly proportional to rho, and also pressure also directly proportional to depth. Okay, that must be from the surface of the liquid. Remember, from the surface of the liquid. So that one is considered as depth. Or you can use symbol D. Depth. Mesti dari permukaan air ke bawah. Kalau ada ikan dekat sini, so from the surface of water to the fish. That is height or depth. Okay. In this one, second experiment in chapter 2. Okay. This one, to study the relationship between depth, H, and pressure. So from the aim, we can know what is the manipulated variable and what is responding variable. So this one, between depth of liquid and pressure. So must be H is manipulated variable, depth is manipulated variable, pressure is responding variable. Okay. Remember this diagram. We have thistle funnel covered with rubber sheet to provide the surface area. Provide surface area for pressure. Okay, then connected to the silicone tube with the U-tube filled. This U-tube we filled with colored water. Okay. Before the experiment, this colored water are in the same level. Dia punya level sama before the experiment. Once you immerse the thistle funnel into the measuring cylinder that full with water in a certain height. This height we want to change the height. Okay, this one we change the height. This one maybe H1 and then H2 deeper and deeper lah. H1 first and then from surface of water to next level is H2 and H3. So this one you you change manipulated variable for H. And then D is the pressure. D present the pressure. Boleh D present the pressure. D we want to measure. So this D is the responding variable. The height. A change in height of the colored water is the pressure. And we presented it by D. Difference in height of water columns. D. Okay. So this one, if we change the depth, deeper. So this one also change. The difference in height also change. Become higher. Dia punya ni akan jadi tinggi. Dia punya perbezaan akan jadi makin besar. So ingat dia punya diagram. So this one for measure H we need a meter rule lah. A meter rule ataupun pembaris biasa. Kalau dekat lab kita guna meter rule to measure the depth. Measure the depth. Depth in cm. In cm. Okay, now. Ini boleh buat sendirilah ayat. Untuk prosedur 5 point. Set up. Number 2, fix or immerse the thistle funnel at 4 cm depth, MV, and then RV. Observe the difference in height of water. And then number 4, repeat. Repeat the experiment with the different depth, 8, 12, 16, 20. Okay, and then 5, plot graph. Plot the graph D against H. Okay, D, H. H is manipulated variable, D responding variable. So, this one is directly proportional. Okay. This one, the second experiment, a relationship between density and pressure. Density and pressure in liquid. So this one is manipulated variable. Pressure is responding variable. So for this experiment, we have two different of liquid, two different density of the liquid. We use alcohol and glycerin. Alcohol and glycerin. Ni lah. Sekejap. Tidur.
Oh no. Awak tak apa?
Kenapa sih?
Hah?
Besok.
Dia lagi. Dia awak kenapa?
Tengok ah.
Asen dah.
Rafiq.
Kau aku main hotel. Jadi,
Mana ni? Ngaca. Okay. Okay, how to carry out the experiment? Use the same same apparatus, tissue funnel. Remember tissue funnel? Takut you tak ingat benda ni. Dia akan bagi another apparatus, but the other one, salah satu dia akan minta you fikir sendiri dia punya apparatus. And then the substance that we need is water and glycerin, beaker B, beaker C, beaker A. One more is alcohol. So got three lah, got three. Alcohol, water and glycerin. So same method, but we need to fix a constant. The constant here is the depth, the height. We mark the height that we want to immerse the tissue funnel. So we mark with, let's say in this experiment it fixed the depth from the surface or from the bottom to the mark is 2 cm. 2 cm, let's say 2 cm. Okay, 2 cm. So this one 2 cm, 2 cm. Mark dengan masking tape. Okay, and then after that we immerse the tissue funnel into the water sampai dekat mark yang kita buat. And then we observe the D for each different of liquid. Okay. So dekat sini constant dia high, yang kita nak measure pressure or difference in height D. Okay, this is the result. Okay, result ni buat result, buat table lah. Okay, lepas tu graph pun sama, directly proportional. Okay, now this one we have a different shape and different area. Good. The cross-sectional area and the shape of a column affect a pressure in liquid. Okay. How cross-sectional area and shape affect the pressure in liquid? Okay, the answer is no. The answer is no. Once you put a liquid into this into this apparatus, the level of water become same. Same level of water. Okay. Yeah, it means that the area and the shape, area and shape does not affect the pressure in liquid. Okay, yang baru masuk tu kita revise chapter 2. Okay. This one to show that pressure act in all direction. Okay, if you put plastic bag filled with water, okay, and then we prick with a needle. Okay, got hole. I make a hole around around the bag, so the water will spurt up in the same pressure. the water will spread up with the same pressure. Same pressure. Okay. If we use this bottle, okay, we make a hole in the same height, or same depth. So the pressure of water are same. Pressure same. Pressure of the water that spread up from the bottle are same, and the distance, horizontal spurt distance also same for all the hole that we make. Okay, distance means from the hole and to the spurt up of water same. Semua sama. Untuk semua lubang semua sama. Because the level of depth are same. Dia punya horizontal spurt distance same because depth also same. Okay. Shows that the pressure at the point in the liquid acts in all direction. Ini konsep. Ni SPM 2018, cannot remember. Yang ni soalan comparison, soalan nombor 5, 6, 7 comparison. So yang ni senang. Dia akan bagi different diagram 6.1, 6.2. You just compare the horizontal spurt distance. Horizontal distance. Compare the pressure. Okay, this one. Okay, we have two diagrams. First diagram only one liquid X. Let's say water only. Okay, then in second diagram we have two different type of liquid X and liquid Y. Maybe water and alcohol or oil. So how to determine or calculate the density of liquid Y or density of liquid X? So this one, we use the equation P equal to rho GH for both of the liquid. For liquid X and for liquid Y. Semua letak simbol, senang. X, this one Y. So letak simbol. Okay. So since the gravitational acceleration are same, so we cancel out for gravity. And then what is left is rho and H. Rho X, HX, and rho Y, HY. So this one will be like this. Okay. Yang dekat bawah, yang third equation. So we use ratio. We use ratio. So from this equation, we can find out either dia punya height or dia punya density. Okay. Soalan akan beri salah satu. Dia akan beri yang H, and then you must find the density, or you are given the density for both liquid and find the H. Either one. Dia mesti akan bagi salah satu lah, and then akan cari satu sahaja. Boleh use ratio. Use ratio for this one. Okay. Solving problem involve pressure in liquid is fine. Right. Okay, for an object in a liquid, okay, there are two pressure exert actually. Okay, first the pressure exerted by the water itself surround the fish. Let's say this fish, okay, exerted by two pressure of the water, okay, and second is pressure, atmospheric pressure, PATM. Atmospheric pressure. So there are two pressure that exert for the object in a liquid. Okay. So actual pressure for this fish, actual pressure for this fish, PACT. Actual pressure equal to pressure that exerted by the water water surround the fish, and then the atmospheric pressure. So we must add this together to find the actual pressure exerted to the fish. Okay, then actual pressure equal to water pressure and atmospheric pressure. That is for actual pressure. Okay, let's see the example here. We have a fish at depth 0.5 meter H. Okay, this one presented by H in an aquarium. The density of water in the aquarium is, okay, this one density for water, and atmospheric pressure is 100. So this one is P ATM. Right. What is the pressure experienced by the fish caused by the water around it? So this one dia hanya nak tahu the pressure of water. Experienced by the fish caused by the water around it. Pressure caused by water. So P equal to rho G H. Rho G H. Already given the density of water. G. Okay, G. G, you look at the question here. G that we use 9.81, not 10 anymore. So look at the question. Jangan terus darab 10. Kalau tak you punya jawapan tak accurate lah dengan skema. So convert the G into 9.81 meter per second and height is 1.5 meter. Then you got the answer. The unit for pressure is Pascal. Kita lepas ke? SI unit for pressure is Pascal. Okay, ni lupa nak bagi tahu. SI unit for pressure P is Pascal. SI unit Pascal. But we can use also Newton meter -2. This one from F over A. This one from the equation F over A. Newton meter -2. Or this one come from apa ni? FMG from M. Kita ada dua. P rho G H. Rho G H. This one from rho G H. Okay, this one from rho G H. From rho G H. Rho in kilogram meter. Ni boleh derive tak? P density is kilogram over volume. M -2. Density. Gravity is M juga S -2. Right. For G, gravity or acceleration, ms -2. And then H is M. So from this rho GH, the unit become kg. M ada banyak. M cancel out. M jadi M -1 and S -2. Boleh ke tak ni? Okay. So inilah jadinya. Okay, unit for pressure. Either we use the unit from F over A or rho GH. Mana satu depends on question lah. Kalau dia guna Pascal. Kalau soalan tu involve force ke area ke, boleh guna ni ataupun boleh juga guna Pascal. Tengok soalan. Mana tadi? Hilang lah. Okay, this one So this one Pascal. The unit is Pascal. Okay. Calculate the actual pressure. So actual pressure equal to pressure of water caused by water plus ATM pressure. So tambah je. Tambah je dengan atmospheric pressure given in the question. 100 kilopascal. Kilopascal. Be careful with the unit or prefix use. Nanti terlupa nak convert. Okay, dia punya solution A 1.5 meter density and gravity, so we have 15.5 kilopascal. To find the actual pressure, you just add with the atmospheric pressure 100. So the answer is 115.5 kilopascal. Okay. Now this one for comparison between two liquid, pressure for two liquid. Okay, tengok dia dah bagi. Dia bagi H1, H2, P1, so find P2. Dia akan bagi Dia akan bagi ni. So you just substitute into the equation. Just substitute into the equation, cancel out G, H2, H1 P1 equal to H2 P2. So, dapat. Okay. Tengok juga unit. Tengok juga unit yang dia bagi. So meter. So kena tukar nanti. Okay. Now application. Okay. Habis ni. Application of pressure in liquid. Okay, we place the water tank at higher place. In the space between the ceiling and the roof, means higher place, higher position or higher depth. Okay. Why? To produce higher pressure. Produce higher pressure. Okay. And to make sure that the water flows at high speed when the tap is open. Okay. Number 2, position of intravenous liquid. Natrium, sodium chloride, garam, air garam. So this one also we need to put it higher, higher than our arm, our hand. So that's why we use this stand. Bila you nak ke tandas pun you kena bawa sekali dengan stand. If you bring this, kalau you hold sahaja benda ni, dia akan jadi sama level dengan you punya tangan. So darah nanti yang akan keluar masuk dalam ni. Darah yang akan keluar bila you bawa dengan tangan. So that's why nak pergi tandas ke, pergi mana ke, you kena bawa sekali dengan stand. To make sure dia punya, so that's why nak pergi tandas ke, pergi mana ke, you kena bawa sekali dengan stand. To make sure dia punya position higher. Okay. This one sama juga to increase the pressure. Increase the pressure. But we also have adjuster to make sure the flow of the liquid here, the salt here, can be, the rate of flow can be adjusted. Tak adalah banyak sangat, tak adalah cepat sangat. Just a little drop for 1 minute. Okay, next, construction of a dam. See, bulk thicker to stand the water pressure. To stand the water pressure, bulk thicker at the base. Stand the pressure that increase with depth. We know that pressure increase if depth increase, right? So that's why the bulk is thicker at the base. Okay, and then the penstock is at the lower section to produce a fast flow of water, velocity of water increase. Okay, this one use of siphon ni PT3 pun dah ada yang tanya soalan kebat yang last kali use of siphon. So ni dah biasa. Satu high location, high place. Second one is lower place, lower region, dia panggil region. Higher region to lower region. Okay, samalah to increase the pressure. Ni ketiga dah ada, kena explain sendiri. Okay. Yang ni tahu kan before you put the siphon into the aquarium and pail, you must insert water. Okay, kena masukkan, penuhkan air dalam sifon dulu. Close with your finger at the end, A and D ni, close with your finger, and then baru masukkan dalam aquarium and release water. Then the atmospheric pressure will push the water into the pail. Ya, cara dia. Penuhkan air dulu dalam sifon, baru masukkan dalam aquarium. Okay, finish. Finish 2.1. Okay, the three factors affect the pressure. We have density, we have H, we have gravity. Three factors. Okay, what is the water pressure at depth of 24 meter in a lake? Yeah, 24 meter in a lake. So just substitute into equation rho GH. Rho dah ada, density dah ada, gravity dah ada, H dah ada. Kira je dalam Pascal. Kumat ranam. Who's kumat ranam? Is in 5A. Right, number 3, a diver dives to a depth of 35 meter. So this H. What is the actual pressure? Actual pressure acting on his body. So look at the question. You are given atmospheric pressure 100 kilopascal. You just find out the pressure of water equal to rho GH. Rho given water, density of water here rho, and then G 9.81 and H 35 meter. And then to find the actual pressure, you just tambah. Okay, tambah saja. Okay. Boleh Baik. Tengok ada soalan tak untuk yang pressure ni? Nak tengok exercise yang SPM punya. Okay, boleh nampak ke tak nampak? Number 13. Number 13. Diagram 1 shows 3 similar balls X, Y, Z full immersed in olive oil, glycerin and turpentine. So different liquid, different density of liquid. The depth same. Okay, the type of thread and weight also same. So the question is, which ball experience the lowest pressure? Bagi jawapan. So boleh bagi jawapan? Apa jawapan dia? Yang mana satu? Nampak ke tak ni soalan? Apa jawapan dia? Boleh tulis dekat chat. Devin? Number 13. We have different density of liquid, same weight of object. So which one experience the lowest pressure? P lowest mean dia punya depth sama, G sama. So to make the pressure lowest, the density also must be lowest. So which one? Okay, C good Shamita. Rong Puan kenapa Z tu mana? Okay, Z, okay. Z C. Okay, the answer is C. 14, alamak. Soalan kat atas. Jawapan kat atas, soalan kat bawah. Okay, tengok dulu. Diagram 8 shows an apparatus set up to measure pressure in liquid. We have P and Q. Water level at P, water level at Q. And then we have a height or depth. Pressure. This one present the pressure. This H represent the pressure or D. Experiment D. D represent for pressure. So soalan tanya, what happened to the height of water H if the tissue funnel is lower from P to Q? From P to Q, the tissue funnel, okay, lowered from P to Q. What happened to the H? H yang dekat atas tadi. What happened to H? So, ada jawapan? What happened to H? Is it increase, decrease, or no change? Woon and Rung B. Kim Fai A. Okay, the answer is A. Increase. Why increase? Why? I just mentioned that H refer to pressure, right? H refer to pressure. So what happen if you lower the tissue funnel to Q means it become deeper. So if depth increase, pressure also increase. So means that pressure increase here is the height. The height also increase, dia punya D. Dia guna simbol sama, so confused. So dekat sini pressure increase, H increase lah. Means that pressure increase, so this one H also increase. Because of the depth here increase, or H increase. H ni from the equation rho GH. So saya lebih suka H ni suka tukar kepada D, depth. Okay, number 15. Diagram 1 shows the apparatus to measure water pressure. Okay, we have same apparatus, tissue funnel. What is the water pressure at X? Okay, you are given atmospheric pressure equal to 75 cm mercury. Dia guna unit cm mercury. Then when you immerse into the water at X, so there are difference in height. Dia punya height dekat sini ataupun pressure dekat sini 3.8. So what is the pressure at X? Apa pressure dekat X? Macam mana nak kira ni? Macam mana nak kira? Ada yang dapat jawapan? Macam mana nak kira? Okay. So this one considered as actual pressure of X. Actual pressure of X equal to atmospheric pressure plus pressure exerted by water. So we already know that atmospheric pressure is 75 cm mercury. So tengok dia punya jawapan pun semua guna cm mercury. So dia punya water pressure, you just take out from the high here, from the difference in high here, because the difference is the difference in high represent the pressure, right? Represent the pressure. So this one become 3.8 cm mercury. Tambah sahaja. Tak payah nak fikir banyak. Tengok dia punya difference in high dekat sini. So 78.8 cm mercury. Okay, the answer is C. Boleh Boleh ingat cara nak kira? Dia akan bagi. Ini dia akan bagi. atmospheric pressure. 75, kalau sekarang dalam punya textbook, kita guna 76, 76 cm mercury or 760 millimeter mercury or 0.76 meter mercury. Tengok soalan dia guna prefix yang mana, cm or mm or meter. So tapi nilai dia sama, nilai sama. Okay, number 16. Diagram 7 shows an empty bottle tied to a load in the water. Okay, tengok. Botol ni botol kosong, empty bottle. Okay, tied to a load in the water. Kita ada load, kita ada string. Okay, question is, which changes will increase the pressure on the bottle? Which changes will increase the pressure on the bottle? Kita nak increase pressure dekat dalam botol. So, yang mana satu betul? We know that P equal to rho GH. Which factor that we can change according to the diagram above? Density. Can we change the density of water? Cannot. Right. So, next, can we change the gravitational acceleration? Also cannot. So now here on the left, the depth, height. So how to change the height? How to change the height? B. Okay, shape. B. Yes, the answer is B. So means we make the depth deeper. How to make the depth deeper? So we must lower down the bottle. How to make the bottle lower down? To make it deeper, so we must shorter the string. Make the string shorter. Boleh Boleh faham You relate dengan equation. Selalu relate dengan equation. So 8:30 now. Okay. Habiskan soalan kat sini. Alright. 17 diagram shows different liquid spurts out of containers. Spurts out of their containers. Right. Okay. Spurt distance for each liquid is X, Y, and Z. Okay, we have water, oil, and salt water. Which arrangement is correct? Which arrangement is correct? Ini pun saya macam salah lah dia punya simbol ni. Simbol dia. Okay. Yang mana satu? Relate juga dengan equation P equal to rho GH. So dekat sini the question use different density, right? Different density. Dia punya depth sama. Level of depth semua sama, same. So H tak ada kaitan, G pun tak ada kaitan. So density. So if more denser increase, density increase, density increase, pressure also increase. So dia punya spurts of distance also increase. Spurt of distance also increase. So which one? Oil, water, salt water. Which one is the more denser? ZXY. ZXY. Yes, the answer is C. Yes, Joanna's motion answer is C. We know that Y Y is the less dense. Less than. Why less than? Oil. Oil dekat atas minyak. And salt water is more denser. Right, 18 diagram shows water. Ada apa? Iklan. Iklan sekejap. Aduh, ya Allah. Bercakap dengan ni. Okay. Ada 18. Okay, 18. The observation shows that white. Okay, we look at the spot distance in different level. So what's the answer? Is it related with the volume? No. Volume? No. So we have C and D. C okay. Shamita C. Yes, C 15. C. Okay class, can we dismiss now? Saya pun nak pergi sekolah ni. Dismiss dekat sini dulu Okay, yang next ni kita bincang. Okay Kuan Siong attendance. Okay, bye. Bye. Tu ada anak. Okay.